Hello students, this is your Bhushan sir. Hope all of you are safe and fine at home. Have you all downloaded Arogya Setu app during this pandemic time? If yes, you all are in a way cautioned about your surroundings in relation to COVID-19. If your answer is no, then as per government, we need to download this app as it is useful. You know, the working of this app is dependent on the technology what we are going to discuss today, that is remote sensing. Let's now understand a very classical example pertaining to remote sensing, that is working of our human eye. The vision of eye is the collection of information about an object that gets exposed to the light source. That is, when light falls on an object, some radiations of the source gets absorbed and some gets reflected back. This reflected rays of the object gets collected as an image by our eyes. So, our eyes now can collect the reflected rays and send it to the optic nerve, which will frame the image in the brain. Here, never our eyes comes in contact with the object. Being placed at a distant location, eyes could sensitize the object with the help of light radiations as source. The second example is the operation of our TV remote. By keeping ourselves at a far distance, we can operate TV using a remote instrument without coming in contact with the TV object. Therefore, any objects whose image or phenomena is sensitized by not having contact with the object but with the help of radiations of light source is called remote sensing. Remote sensing is the word which refers to remote means far or distance, sensing means collection or gathering of information. So, remote sensing generally means collection of information of objects or phenomena without coming in contact with it. Remote sensing is therefore defined as a scientific technique of obtaining information about an object or a process that takes place on Earth without being in contact with the object. As the information here is of the Earth, what we observe or gather, the remote sensing technology is also called as Earth observation technique or technology. Way back in 1950s, Ms. Evelyn Pruitt used the term remote sensing for the first time in Naval Research of United States. Let's now discuss the history of remote sensing. It was in 1859, Gaspard used this technology of remote sensing in taking a photograph of a small village near Paris using tethered balloon which was fitted with a camera in it. You can see such large balloons hang near the malls to hint its location even today. You can see the same in the picture of this slide. Later, during the First World War, military forces used to record the information of their neighboring areas using the camera which were fitted to the aeroplanes. Students, remember, here the cameras are called the sensors to gather the information about the Earth. Sensors in case 1 position of it when we look at in the tethered balloons, they were fixed to the balloons, whereas the platform of sensors of our camera during the First World War gets changes to the aerial platform, which is slightly away from the Earth's surface, and the area information what it gathers is slowly gets magnified here. The third platform is the cameras were later fixed to the spatial area using the satellites, which started to record the information of a very large geographical area. It was done between 1960s and 1970s very widely. And this technology is also called as satellite remote sensing, because satellites contain the sensors. Those sensors will gather the information about the Earth, and hence it is called satellite remote sensing. This technology of satellite remote sensing is widely used to gather the information about the Earth, hence it is called the geographical information system in later days. Excuse me. It is also widely used to gather the information about the forest, line of control, the LOC, then to record the agricultural fields, then water resources, etc. All the information is in the form of scientific drawing in the satellite remote sensing, which we call it as cartography. Till today, we are following and using this satellite remote sensing technology. Now we shall understand different stages or steps of remote sensing. Before I go in detail about this, in the history of remote sensing, what we have understood is position of sensors or cameras shifted from balloons of tethered kind to aeroplanes, then to satellites. So altitude of fixation of the sensor slowly increases. Thereby, the information what it gathers of geographical area also gets increased. So now we will understand stages of remote sensing. First of all, to record information of an object, the object should be visible. So object should be present and it should be visible. So visibility of an object requires an energy source or a light source. This energy or light source could be a natural or an artificial resource. Sunlight, which is a natural energy resource, and radars are artificial energy resources. Whichever the type of energy resources let that be, it has to emit electromagnetic radiations. In short, we call it as EMRs. The second type is, or step is, interaction of EMR with the objects. Here, the source of energy emits EMR that will strike the object. Now, the same energy, some energy of EMR gets absorbed by the object and some energy gets reflected back. This back reflected radiations are sensitized by an instrument of camera or sensor. In the picture you can see the sun is radiating the energy, which is a source, which strikes the object and some energy gets reflected back, which is collected by the sensor or the camera fitted in the satellite here. The next stage is the information what the sensor collects is recorded as data. This data is later sent to the sensor data output, where the transmitted data is processed and analyzed for further study. That's what you see in the picture in the slide here. Now, we shall understand the working principle of remote sensing. Students, The working principle of remote sensing depends on the energy source and the property of material or the object. Intensity and wavelength of radiations are related to the energy resource. Surface roughness and ability of absorbing and reflecting radiations are the factors related to the property of material here. The next important concept that we shall understand is classification of remote sensing. Classification of remote sensing is based on source of EMR. If the EMR is from a natural source like sunlight, as what you see in the second picture of the photograph that's there in the slide, it is called passive remote sensing. It is called passive because it can emit the radiations only during daytime, and information about the earth cannot be collected during night time. So energy resource won't be there during night time. So sensors will not work during night time. So this is about the passive remote sensing. Coming into the first picture of this slide, a photograph what we have there, it is called active remote sensing. If the EMR is from an artificial energy resource which is active both day and night time, it is called active remote sensing. Generally radars are used in this particular type, which is used in satellite remote sensing very widely. Students, remember, in active remote sensing, the sensors and the source of emission of EMR both remains together by the same source. So that's about the importance of active remote sensing. The next is types of remote sensing. We have many types of remote sensing, but in your syllabus only 2 types are mentioned, which we shall understand now. The first type we shall understand is satellite remote sensing. Satellites are man-made vehicles which will carry the sensors like camera to a very high altitudes away from the earth to gather the information about the earth. So satellites are equipped with the sensors of one or many. These are hence called as remote sensing satellites. Satellites are generally sent to specific orbits of the earth in space, which would be around 600 to 1000 kilometers away from the earth's surface. Satellite orbits are generally referred as the imaginary paths for the satellites. So orbits are imaginary paths for the satellites surrounding the earth.